Chapter 2, Section 9 is called Percents, and your goal is to be able to write and solve a proportion and then apply it to a real life situation. The first thing we're going to talk about is called the percent proportion. We've been talking about proportions for a couple sections. A proportion is when two ratios are equal to each other. Okay, so in this case, it says you can represent A as P percent of B using the percent proportion shown below. In the proportion, B is the base and A is a part of the base. So this is how I like to think about it. The part over the whole is equal to the percent over 100. A whole object is the same as having 100% of it. Part of the object is only a percent. We just don't know which percent. Okay, and when I'm reading a word problem, the word is almost always tells me which number is the part, and the word of almost always tells me which number is the whole amount. Okay, we're going to try that percent proportion just for a couple of these. We're wondering what percent of 56 is 42. Okay, so percent is what I don't know. So here's where I'm going to put my variable. Is my part, or 42 is my part, because we know that in this case 56 is our whole. So we're going to put 42 on top, 56 on the bottom, and that's going to equal x out of 100. Okay, now I can solve it by doing my cross multiplying. And I find I have 4200 equals 56 times x. Then I can divide by 56, and that tells me that 42 is okay. Next question asks us what percent of 90 is 54. So they're telling us that 90 is the whole amount, 54 is our part, and we always know 100 goes on the bottom, and then because they don't tell us the percent, this word what tells me that's where my variable goes. Okay, now when I do cross multiplication, I get 54 times 100 and 90 times x. And when I divide by 90, I find out that 54 is actually 60% of 90. Okay, that's the percent proportion. The other way to solve these is called the percent equation. Okay, and this time, it's the same idea. We still have part and whole, still the is and the of. The only thing different is that this time, if I know a percent, I have to put it in as a decimal, whereas with the percent proportion, you don't have to do that. Okay, so let's practice that a couple times. What percent of 40 is 2.5? Remember that part is, whole is of, so I'm going to plug in what I can. My part is 2.5, so that's going to be equal to my percent, which I don't know, times the whole, which is 40. Okay, to get the x by itself, I'm going to divide by 40. And I'm going to find out that 2.5 divided by 40 gives me 0.0625, but that doesn't make a lot of sense because it's not a percent yet. So I have to move my decimal over 2 places and find out that 2.5 is 6.25% of 40. Okay, working on the second example. What percent of 80 is 63? So my part is 63. I don't know my percent, but my whole is 84. So to get x by itself, I'm going to divide by 84. I get x equals 0.75. Then I need to turn it into a percent, and I find out that 63 is actually 75% of 84. Okay, that's the one extra step. When you're using the percent equation, it's going to give you a decimal. You have to move it 2 places to the right to turn it into a percent. All right, on these two, you can use whichever you prefer. I'll do one of each. What percent of 42 is 28? So here's my x. This is my whole. This is my part. So if I'm doing the percent equation first, I would get 28 equals x times 42. Divide by 42. 28 divided by 42 gives me 0.666666, repeating. If I move my decimal 2 places to the right, that means 28 is 66.7% of 42, approximately, because that's rounded. Okay, I'll do this one as a percent proportion. What percent of 99 is 72? So we go part over whole equals percent over 100. That means 72 over 99 equals x over 100. Cross multiply gives me 7200 equals 99x. And when I divide by 99, that one's already written in percent form, and it is 72.7%. Okay, now you can choose to use, unless the book specifies, you can choose to use whichever method you prefer, the percent equation or the percent proportion from here on out. Okay, Mrs. Waldbillig's Halloween costume originally cost $70, but is on sale today for 60% off. How much will Mrs. Waldbillig pay if she buys it today? Alright, so the first thing that we need to do, this is actually a multi-step percent problem. The first thing I need to do is figure out what is 60% of 70. So if I have 70, that is my whole cost at the moment. 60, that's my percent. I know it's out of 100, so what I'm actually missing is the part. So I'm going to use percent proportion for this one. And I don't know the part, so that's where my x goes. The whole is 70. The percent is 60 out of 100. Alright, so when I cross multiply, I get 100x equals 4200 divided by 100, and x equals 42. Okay, so what that tells me, since this is a sale, 60% of $70 is $42. No, I'm not actually going to get to pay $42. That's what I get to take off because it's a sale, 60% off sale. So my second step is to take my original cost, subtract that 60%, and find out I will only have to pay $28 if I buy that costume today. Okay, a set of golf clubs that cost $600 are on sale for 40% off the regular price. What is the sale price of the clubs? Okay, so same idea. Step one, I have to figure out what 40% really is. 600 is my whole amount. 40 is my percent. So part is what I don't know. So part over whole equals my percent over 100. Okay, when I cross multiply, I get 24,000 equals 100p in this case. Then I divide by 100. That gives me 240 equals my part. So the part that I get to take off, or the 40%, is $240. So now part 2, I need to start with what the original cost was and take away that 40%, or that $240. And that tells me that I'm still going to have to pay $360 for those golf clubs. Okay, retail stores mark their Halloween candy up by about 55%. If the wholesale price of a bag of Halloween candy costs $7, what would the retail price be? Okay, so that means that a store buys their Halloween candy for a certain price, and then they actually make it more expensive, or they mark the cost up for you to buy it at the store. So I have a percent, I have a whole, I need to find the part. I need to find out how much 55% of that 7 is. So part over whole equals percent over 100. When I cross multiply, I'm going to get 7 times 55, which is 385, and then 100 times p. I'll divide by 100, and my part is going to be $3.85. Now this one is not a discount. This is a markup. So I actually, for step 2, have to take the original price and add that extra that the store is going to charge me. And I'll find out that as a retail customer, a normal customer coming in to buy that candy, I'm actually going to have to pay $10.85, even though that company only paid $7 to get it. Okay, let's try one more that's actually a markup. A discount store marks up the merchandise it sells by 55%. If the wholesale price of an item is $25, what should be the retail price? Alright, so again, we have a whole, a percent, and we know that they're marking up. Okay, so part is what I'm missing. My whole is $25. It's always out of 100. And my percent is 55. And when I cross multiply, 25 times 55 gives me 1,375 equals 100 times p divided by 100 gives me 13.75. So $13.75 is how much they're going to mark that up. Okay, so if they paid 25, step 2 here is to take what the store paid for at wholesale, add on what they're going to mark it up, and that tells me that as a retail customer, I am going to have to pay $38.75 for that item. Alright, if you are in regular algebra, this is the end of day 1, and your homework is on page 141, 9 through 30, all, and then the lesson quiz, and you'll have 2 days to